LeetCode Problem number 1584, mean cost to connect all points. So this problem gives us an array, points, which represents the integer coordinates of some points in a 2D plane, where each point would have its respective x and y values. So here it explains the cost of connecting 2 points is going to be using the Manhattan distance, which is the 2x's plus 2x's minus against each other plus the 2y's minus against each other, and the absolute value of it. So the goal is to return the minimum cost to make all the points connected. And here it says all the points are connected if there is exactly one simple path between any 2 points. So basically what it wants us to do is to play connect the dots and find the shortest distance between each dot, right, to form a path. So my approach to this problem is to use something called the Prim's algorithm. So here I have the size, which represents the size of the points. So result is the one we will be returning as the answer. So here I have a visited vector as well. So let's use this example. Okay, and visited, there is 3 false. Okay, same for distance, there will be 3 in maxes. Okay, so visited will keep track of what point we have visited, and distance will keep track of what each distance is. So this priority queue will keep track of which points we are at. We will store the x and y values in greater order, so in ascending order. Okay, once everything is done, we first push in our initialize 0, 0. So basically this would start off from point 0. I'll explain a bit more. So here I have a while loop. So while this priority queue is not empty, so here I have top, which represents the top of the queue. I pop it. So current is the current index we are at. So currently we are at index 0. So this priority queue, I think I misspoke just now, it does not store the x and y values, but it will store the distance and the index of it. Okay, so current is 0, and are we visited in this node? No, because it's false. So we can continue move on. The cost of it is 0 as well. We have not calculated anything. So we mark it as visited first, turn it to true, and we plus equals the result. Well, in this case, cost is 0, so we don't have to change our result. So here I have a for loop. So this for loop, what it will do is it will start from you iterate through all the points and calculate each distance from the respective points to the current point we're at. Okay, excluding the visited nodes. So starting from 0, but since the first point we have already visited, we just continue. So next we increment to 1. So 1 is -2 and 5. That's our next. The distance would be the absolute value of current. Current is 0. So 3 minus -2 plus 12 minus 5. Right? 3 minus -2, 12 minus 5. This will give us 7 here, and this is 5, which would become 12. Okay, so distance, is the distance smaller than the current distance we have registered? It is, because we have put in max. So we are going to update it and push into our priority queue. The distance plus the index of it, which is 1. Okay, Next we'll increment to now 2. So we're looking at -4 and 1. So again, it's not visited. So we have to find distance once again. Distance would be the current 3 minus -4 plus 12 minus 1. Right, so 3 minus -4, 12 minus 1. So this will give us 11. This is 7. In total, 3 minus -4, yeah, this will be 7. So in total, this will be 18. Here I push 18 to 2. Right, 2 would be the index of next. Once that is done, the while loop will keep on going because my priority queue, there's something in my priority queue. So the top is now 12 and 1. Pop it, and the current is 1. So this node is now visited. So we register the cost, which is 12. Mark it as visited. Increment result with the cost. This is 12. Result will be 0 plus 12 is 12. And we begin our for loop again. So again, next starts with 0, but since we have already explored the first point, so we ignore that. Same goes to the second point, so we can only go to the third point. Next will be 2. We calculate the distance. Distance would be 12 minus 4 plus 1. Sorry, it shouldn't be 12. So current is 1, so we're looking at -2. So it is actually -2 minus -4 and 5 minus 1. So this will give us 4. -2 plus 4 will give us 2. Right. Total it will be 6. So is the current distance we have smaller than the distance we have registered for it? So for next is another in max. So in this case it is smaller than it. So we update it to the 6. Afterwards, we push our priority queue another distance. So this will become 6 with 2. Right, with the distance next. Okay, this for loop will end, and priority queue is not empty yet, so we keep on going. Top is now 6 and 2. Pop it. Current is 2. Have we visited this yet? No, we have not visited this node yet. So here we initialize the cost is 6. Mark it as visited, true, and then we increment the result with the cost. 6, result is 12. 12 plus 6 is 18. So we reach another for loop. But for this case, since we have visited all of the points here, so we don't need to calculate any more distances from our current point. So this for loop will be skipped, and then the next for loop, which is 18, stores the current 18, and this 18, if you see here, the current is 2, right? But we have visited this point before, right? It has marked true in our visited vector. So when that happens, we can just skip past this. So what this means is that we have already calculated a shorter path to point to this point, right? So we don't have to calculate it again. We don't have to calculate because the current path, if you can see, the distance is actually 18, right? Which is more than the previous 6, right? Previous 6. So we can just skip past this. Which is also why we use a priority queue and sort it in ascending order, because we want to look at the lowest distance instead of the highest distance, 18, right? So that's why we register this first, we process this first, and since we have already marked this as visited thanks to the second value in our pair, we can just ignore this without needing to pop it, right? Or explicitly remove it from this specific data structure. Anyways, this for loop will end, will exit, and return the result, which in this case is 18. It should be 18. Yep, 18, and you can see here it matches the answer given in the example. Okay, so this specific problem was a bit tricky, but nonetheless, that's all I have to show. Thanks.